Assalamu alaikum everyone. This is Zainab from DICE Analytics. First of all, I would like to welcome you all on behalf of DICE for today's demo class on DevOps. I'm glad to introduce our speaker, Mr. Ali Kahoon, who will be leading this class. Mr. Ali is a software and DevOps engineer with broad experience in software development and developing CI/CD workflows for complex applications consisting of different various microservices. He has been working on tools like Jenkins, Docker containers, Kubernetes, Helm for years. Mr. Ali is currently working as a senior SRE. It's a request to all the attendees to note your questions during the session and ask your queries in the Q&A session at the end. That's all from my side. Thank you so much. Over to Mr. Ali.
Hi everyone. Hi. So Zainab, can you hear me?
Yes.
Thank you. Assalamu alaikum everyone. My name is Muhammad Ali Kahoot, and today I would be basically telling you what is DevOps and how, if you want to move towards DevOps as a career path, so how can you do that? So first of all, about me, my name is Muhammad Ali Kahoot. I am currently working as a senior site reliability engineer at PowerPay. PowerPay is a UK-based fintech company which operates in Africa region. Basically, we manage almost 1 million transactions per day. So I am currently working fully remote from Pakistan for it. Apart from it, I am a DevOps consultant at Dalil. It's again a fintech-based startup. I'm a consultant over there. I was previously a former senior DevOps engineer at Tarabut Gateway, which is a Bahrain-based fintech startup which focused on open banking. I have been a DevOps trainer at DICE Analytics for, I would say, more than 2 years now. We have managed more than almost 9 batches, and I have trained more than 500 resources on DevOps and Kubernetes. I am a DevOps consultant as well, working as freelance, basically training or giving consultancy-based services. I was the previous team lead at Stakeator Aurora Solutions in the DevOps team, where we used to give managed DevOps as a service solution to our Swedish customers. Apart from that, I was at the ex-software engineer at Bentley Systems. I graduated from FAST as in computer science. I am an avid open source contributor. I have contributed to a lot of Helm chart repositories, to a lot of Red Hat repositories based on Kubernetes and OpenShift. I am certified in Kubernetes, in Oracle Cloud, and in OpenShift, basically, which is the Kubernetes version of Red Hat, you can say, which gives a lot of additions on top of Kubernetes. I have a blog on Kubernetes with more than 163K views and 2.3K claps on Medium. And I have given a lot of talks based on that blog on data and on data on Kubernetes community and other communities. I have trained more than 500 resources. I am certified DevOps expert in Docker, Kubernetes, and DevOps from Pluralsight. I have been a public speaker at DevOps Singapore, Google DevFest, SNP, Global DevOps Week, and Data on Kubernetes community. So just to tell you a brief introduction of mine, that what I have done till now, because what I try to preach to my students at DevOps is completely hands-on sort of a course or a training, that if the person who would be delivering or who would be telling you things, if he does not have hands-on, so I'm just creating my case for you that I have enough hands-on at my hand. So agenda for today would be, what is DevOps, agile versus DevOps, what are the DevOps trends, how and why you should move to DevOps as of now, DevOps best practices, what is CI/CD, you might have heard about it, what does the CI/CD pipeline do, and what different technologies or a different roadmap if you want to move to DevOps field. So starting from what is DevOps and what do I need to do when I want to move towards DevOps. So starting from the problem that why DevOps is so popular nowadays and it was not popular previously. So in 2010s, I would say in 2000 to 2010, basically, what happened was that software engineers were quite in demand. Even today, they are in demand. I'm not saying that they are not in demand, but at that time, even they were more in demand. Why? Because every company wanted software for his applications. For example, if there was a company, it wanted a mobile application, it wanted a website, it wanted a web application, and a lot of those things. So software engineers were progressing, a lot of people were moving towards it, and software engineers as a whole were quite in demand at those days. But now in 2022, most of the companies, or even I would say that 90% of the companies already have a mobile application or already have a website. So they have an existing software. Now they want to manage it. Now they want to add updates to it. They want to add new features on top of it. So now it's not just about creating a software and showing it to your customers. Now what it's all about to manage that infrastructure, to deploy new features continuously. So all of this now comes back to how would you deploy new features frequently? Because if in today's world you lag behind, your competitor would obviously take advantage of that. So for example, the Snapchat stories feature, if I tell you. So Snapchat had a feature of stories, and you can see that similarly, Facebook, it copied, or you can say it inspired and added that same feature into all of its applications. WhatsApp now has a stories feature, Facebook has it, Instagram has it. So all of those now have a stories feature. So if Snapchat now lags behind, Facebook would obviously gain the market advantage, and Snapchat would be left behind. So nowadays, as a company, you need new features frequently. Then the other issue, as the market is totally dependent on software, as we all are dependent on software, so if there is a downtime, if there is an issue, if there is a bug in your application, it would get noticed quite frequently. For example, I would say 6 months ago or a year ago, Facebook had an outage, and you know that it suffered billions in losses when Facebook had that outage and Facebook had that downtime. Similarly, Google had some outages. YouTube went down. Google authentication basically stopped working. Recently, Uber had a security breach and a security hack. So all of these, you can see that now the more focus is now to maintain the feature in a secure way, maintain the feature or deploy new features frequently and get the market advantage. So what happens now is now the blame starts shifting, because if you can see now, these are two parallel lines. First line is to develop a new software. Other line is to manage the infrastructure, to manage the deployed software, what has already been deployed. So now what happens is that the developers would start blaming the QA guys or the infrastructure guys, and infrastructure guys would start blaming the developers that this is because of you, the software doesn't work. The developer says that it works on my machine, so I have nothing to do with it. So all of these things basically result up in days to release a new version of a software. Now let me just turn on the pointer as well. So now what will happen, that a new version of a software or a new feature would take days to release. Then you will take the customer feedback, and customer will tell you about the changes, and then you will make changes, and then whole process is repeated. Also, one other point, if you are in the software industry, you would know that the customer never knows what he wants. So you will ask, previously, if you remember, if anyone of you has heard about software engineering and those practices, so previously there were requirements gathering engineers which went to the customer and gathered all the requirements and those things, and obviously a lot of delays. And then when you showed the software to the customer says that I don't want this, I asked for something else. But in actual, this miscommunication can happen quite frequently. So if you take days to release your software or a new feature of your software, then obviously when you will show the feedback to the customer, then he will tell you the feedback, he will ask for changes, and then the whole process would be repeated, which would result in months of releasing a new feature, which is actually helpful for the customer. So again, the one of the biggest issue that you might have heard about, you might have read some memes about it or whatever, that it's worked fine in dev, but now it's ops problem. So developers, what they tend to say, that if it's working on my machine, then why should I worry, or why should I be care about why it's not working in the production environment? That's ops problem now. Ops people, now it's their problem who handle the infrastructure. So just to give you the context, if you are relatively new to the field, so whenever you release, because I can see some graduates, I believe, or in university students as well in the participants list. So I just want to clarify you all to give you some context about it. So what happens is, when you release a software, a developer codes his features or whatever software he writes, then it goes to a pre-production environment. That can be a dev environment, that can be a staging environment, sandbox environment, and then comes the actual production environment. It doesn't happen that developer writes the code and it automatically goes to the production environment. Obviously, there should be pre-checks, because if there is a bug in the software, it can be captured in the pre-prod environments. So the biggest issue that comes is that it worked fine on the developer's machine, but now it's not working on the pre-prod environment, on the staging environment, or on the production environment. And normally the developers, they don't have a privileged access on the production environment, because due to security features or security implementation, the developers, they don't have that privileged access on the production environment, on the production servers. So now they say that we don't have permissions, we can't debug it. Now it's the ops problem. Now they need to fix it. Just to keep it interactive and to basically find out your views, why do you think that this issue occurs, that the same piece of software, it's working fine in the dev machine, but now it's not working on the prod machine? So what do you guys think? If you have any idea about it, you can write in the chat, or can try to unmute and tell the answer. Different code? No, I'm saying the same exact code. Let's say it's the same exact code, same code that is being run on the developer's machine, but now it does not run on the prod machine. Why could that be?
सर बेसिकली जो डेवऑप्स का डेवलपर होता है उसका एक अकेला बंदा टेस्ट कर रहा है. इवेंचुअली जब आप उसको सर्वर पर लोड करोगे, लोड बढ़ता है, टेस्टिंग बढ़ जाती है, स्ट्रेस बढ़ जाता है, द अमाउंट ऑफ टाइम्स अ फंक्शन इज यूज्ड वो काफी ज्यादा बढ़ जाता है. अगेन ट्रैफिक ज्यादा हो जाती है उस पूरे आपके प्रोडक्ट के ऊपर, तो इवेंचुअली वो उसको इफेक्ट करेगी, उसकी प्रोडक्टिविटी को इफेक्ट करने पे आ जाता है. डेवलपर की तो एक ही मशीन है, एक ही बंदा उसको यूज कर रहा है.
नहीं, अगेन मैं उसकी बात नहीं कर रहा कि लेट्स से लोड बढ़ गया तो आपकी सॉफ्टवेयर चलना बंद हो गया. वो भी ऑब्वियसली एक बहुत मतलब आपने सही कहा, एक जेन्युइन इशू है. बट मैं भी ये बात करूं कि लेट्स से वही सॉफ्टवेयर है जो कि मेरी मशीन पे चल रहा है, अब वो प्रोडक्शन में चल ही नहीं रहा, मतलब इट्स नॉट कंपैटिबल.
Sir, the thing is
Well-
dependency. Like most of the software होता ये है कि हम different versions use कर रहे होते हैं. Different PHP. अगर हम बिलफर्ज हम एक बात करें कोई PHP एप्लीकेशन की, तो जो हम dev environment में हम use कर रहे होते हैं PHP का वर्जन, वो जो है वो इंस्टॉल नहीं होता एज अ पैकेज प्रोडक्शन में. तो इस तरह की चीजें होती हैं जिसकी वजह से ये रन नहीं कर रहा होता.
सही.
So we can say the dependencies.
हाँ, एक चीज डिपेंडेंसीज बिल्कुल सही
Yes.
आपने कही, डिपेंडेंसीज का इशू आता है. अच्छा, मैं इसको थोड़ा सा और डिटेल में बता देता हूँ कि बेसिकली व्हाट हैपेंस इज, फॉर एग्जांपल यू आर वर्किंग ऑन योर लोकल मशीन, आपकी लोकल मशीन पे यू हैव यूबंटू इंस्टॉल्ड एंड यू हैव जावा फॉर एग्जांपल 13 इंस्टॉल्ड और जावा 17 इंस्टॉल्ड. बट in the production environment, Ubuntu is normally considered to be a dev OS. But in the production environments, Ubuntu is not used, or Ubuntu OS or such OSs are not used. They are enterprise Linuxes, which are used because of security, because of other things. In production, normal Ubuntu is not used, but proper enterprise Linux or enterprise OS, which is completely secure, or which has multiple security patches involved in it. I believe someone is trying to annotate on the screen. So yeah. So, and obviously you, for example, install Java 17, but let's say the in the production environment, the Red Hat Enterprise Linux, the Java 17 is still not publicly available in their package manager. So in Ubuntu, basically, when you ran apt get install Java, So Java 13.9.8, for example, got installed. But in production, when it was a Red Hat Enterprise Linux, now when you install Java over there, so now Java 13 or Java 17.8.5 was installed. So previously it was 9, now it's 5, and your code was working fine locally, but now it would not be working over there because the versions dependency issue is there. Secondly, databases or similarly other such and you are dependent on other software. Then again, next issue that can occur is ports. So for example, if you're in your local machine, you are running your one application that is running fine, and that runs on the port 8080, for example. But when the your code goes to the production environment, obviously on the production environment, there would be multiple apps running, not just your app running. There would be multiple apps, multiple teams obviously are working over there. So what can happen is that your app was trying to run on 8080, but another app is already running on the port 8080. So now again, a port conflict or anything of such sort would occur, and now your application would not be able to run. Then the third issue, dependency conflicts. So my application needs Java 17, but any other application needs Java 13 to work. So now we have a conflict. How would you install two Javas on the same production machine, production server, and both application would need their specific Java to work on it? So all of these issues can occur at that time. TB migration issue, dev environment. So I'm just reading the chat over here. Developer don't have exact knowledge of prod environment. Yeah, obviously, that is what I said. Compatibility issue, dev environments have limitations that ops people don't give heed to. Yeah, obviously, rather it's the other way around. Dev people have given a lot of permissions to their machines, to their dev environments, which on the production environments, obviously, we cannot give because of security issues. So that's the other way around, not this. Muhammad Ihtisham, sir, my question is, please define what is the future after this training in context of job. So yeah, I will come back to it in the end. First, try to understand what DevOps is. I believe most of you guys would be jumping on that. Okay, what is the future? Or where should I go? First, try to understand what DevOps is. If that matches your interest, then try to move forward towards it, because obviously all of these questions would be answered automatically in the training. But for me, I am just trying to tell you what actually DevOps is and will it match to your interest or not. So first, let's understand it that way. Then obviously at the end, I would be more than happy to answer all of your questions. So yeah, what is the result? The product delivery cycle continues to move slower and slower. Fewer and lesser ambitious projects are taken. The organization is no longer able to provide stable and reliable services. Obviously, if there are a lot of downtimes, the customer would move to any other company or your competitor. So there was a survey that if your app is, I believe, 0.05 second or 0.5 seconds slower, the customer would move away from your website. If you have an e-commerce sort of a website and your app is slower, then the customer would obviously shut your website and move to any other competitor, because there are so many options in the market as of now. So what happened was, now let's understand the software delivery life cycle. So what happened was, previously there was a waterfall model that, for example, if you have to deliver a software in 4 months, so the first month or first 2 weeks, you just discovered, you got the requirements, you made the architecture, you made those things and all of those things. Then you planned upon it, then you built it, and then you deployed it to the production server and reviewed it from the customer. But as I said, that customer doesn't know what he wants. Now, after all these 4 months, customer says, I don't want this, I want changes. So now again, this was the waterfall methodology of software delivery lifecycle or software development lifecycle, which is now not in practice because of these issues. Then came the agile methodology. Most of you would have heard about it. Agile was the groundbreaking sort of a software development lifecycle, you can say, or a approach towards it. So what it said was that you can break your total lifetime into smaller sprints, into smaller iterations. So for example, if you had 4 months, you can divide it into 3 or 4 sprints of 1 month. So for example, this was one iteration. So we will give for example, or we will deliver 4 features at the end of this iteration. We will deliver another 4 features at the end of this iteration, and we will deliver the last 4 features in this iteration. And then obviously, if after this iteration the customer says that I don't want these things, or he wants some changes in the software, then obviously you can incorporate it in the next iteration. So this was agile methodology that said that to divide your actual time into iterations, work on iterations. Nowadays 2 weeks iteration or 1 week iteration is quite common if you are familiar with the software industry. So there are 2 weeks iteration or a 1 week iteration, which you commit that, okay, in this iteration we will try to basically finish, or we will try to deliver 2 features or 3 features, and then you try to complete that in that iteration. And then in the next iteration you take feedback and you basically incorporate that feedback in the next iterations. What DevOps says is, DevOps says don't even wait for the iteration to end. So for over here, if your iteration was of 1 month, for example, and your feature was completed in the first week, you will still be waiting for the iteration to end to release your software. DevOps basically says if the software is correct, if the software is error free, you can deploy it to prod. So over here you can see design. Okay, design would obviously take time because you need to plan the architecture, you need to plan how you would go about it. Then code one feature, test that feature, deploy that feature. Then take another feature, code that feature, test that feature, deploy that feature. You do not have to wait for anyone else for deploying. So DevOps actually means to deploy your code as soon as it seems to be fine. Obviously, the testing part and making sure that the software is fine, that is the hardest part, and that is what automation and DevOps does. So, but the principle of DevOps, what it says is that if the code is correct, you can deploy it into the production environment. Again, a difference between Agile and DevOps was that Agile mostly focuses on the customer and developer. So there were Agile coaches, there were product managers, which communicated with the customer, and customer gave the requirements and you got the requirements. Then the product manager broke them into stories, into epics, and the developer would obviously be working on that topics. But Agile doesn't cover how would a developer and how would operations guy within the same team, within the same company would be working together. They just focus on the customer part. So Agile mostly focuses on the customer and how to deliver your software to the customer. But how will you deliver or how will you release the software? Agile doesn't cover that. That is where DevOps comes in. And that is where I told you that if the code is correct, you can deploy it. And again, DevOps is not eliminating Agile. You can see again over here, DevOps is not eliminating Agile. Again, Agile would still be there. Agile methodologies are still there. You would be focusing on the customer and developer part. You can promise the customer that, okay, I would release this feature by the end of the week. But as DevOps, or basically due to the combination of the developers and the operations guys, you can deploy the software as soon as it is ready and do your internal testing and do your alpha beta testing and those sort of testings. But Agile and DevOps are both a combination of things. It's not that DevOps is eliminating Agile in every way. Continuous, okay, what does DevOps actually mean is continuous feedback, quick release or fail process. So if the code is correct, you release it. If the code is not correct, if there is a bug in your code, you fail the process and you tell the developer. If code is correct, release and take feedback from the stakeholder. If error, fail fast and give feedback to developer. So this is again an aspect of DevOps that previously what happened was that you took feedback or for example, you ran the pipeline on the nights or on the weekends, and then you get to know that your software has error or your code has error. Then after that week, you got the feedback that, okay, as a developer, you got the feedback that code is not correct. Now you will have to work again on that feature. So DevOps basically means if the code is not correct, tell the developer as soon as possible with the help of automated pipelines and other things. What is DevOps? So whenever you basically sorry. So whenever you Google the DevOps for DevOps, you will always find this image over there. This is a basic DevOps philosophy image or an architectural image. So what this cycle does is that you plan your code, that how I would be working on it. So, okay, this feature would be divided into this dependency would be used, this database would be used or whatever. Then you code it, then you build it, test it on a non-prod environment. Again, as I mentioned, that there are non-prod environments before the actual production environment. You test it, then you release it to production, you deploy it, operate on it, and monitor it. DevOps is the whole combination of it. So then you plan another feature, then you again work on it. So this is the complete cycle of DevOps that is continuous. You cannot say that, okay, my sprint has ended, so now my work is finished. In DevOps philosophy, the work never ends because it's a rerunning cycle. These are some official definitions of DevOps from Wikipedia, for example. DevOps is a combination of software development and IT operations. DevOps is a set of software development practices that aims to shorten the systems in close alignment with business objectives. Again, this is a formal definition. I would not go into much detail. You can read it yourself, or you can Google it as well. So, but what I would try to tell you, or what in the layman terms, what my definition of DevOps is, in a complete layman terms, is DevOps ultimately means deploying and maintaining. So you are deploying new features as well as maintaining the already deployed feature. So if an error occurs or if a sort of a downtime occurs, you would be responsible for it. Deploying and maintaining correct and error-free code from a developer's machine on a scalable and secure infrastructure to revenue generating prod awesomeness. So what basically this means is that you take the code from a developer's machine, you test it out, whether it's error-free, whether it's correct, whether it does what it is supposed to do on a scalable and secure infrastructure. So obviously a developer's machine is not secure, or a simple server is not secure. You have to cater to what's a secure infrastructure. You have to cater to what's a scalable infrastructure. If there is load, so one participant in the start, he said that, okay, there might be load and your software stops working. As you can see the FBR website. So in, I believe 30th September is the last day of filing tax. And most of us know that on 29th and 30th September, their website would be totally down. I'm not blaming them, or I'm not basically saying that they are not correct, but that's not a scalable infrastructure. A scalable infrastructure is like Daraz, for example. They give out a Black Friday sale, they give out a 11/11 sale, the 11/11 sale, 11th November sale. Their infrastructure doesn't stop working. That's a scalable infrastructure, because what you can see that if there is load on Daraz website at a normal day, for example, 10,000 customers visit Daraz, for example, on a normal day. But on a sale day, obviously, there would be millions of people going to Daraz website, and their website doesn't slow, their website doesn't crash. That's a good infrastructure, or the scalable infrastructure. And obviously, the main purpose is to generate revenue. Obviously, the company is not there to for charity. Obviously, the company wants to generate revenue. So at the end, everything comes back to generating prod revenue. And obviously, once the revenue is generated, then the company would be able to give you salaries or those things. Now, coming to what's a DevOps engineer job responsibility. So this is DevOps principles, and what is DevOps engineer responsibility is to automate everything from a developer's machine to production server. Everything in between is the job responsibility of a DevOps engineer. He has to create pipelines to deploy that software to production. He has to create scalable infrastructure. He has to create a secure infrastructure. So if you see, if any application, obviously it would be needing an infrastructure where it would run, that would need servers, that would need networking, that would need storage, that would need container engine, infrastructure automation, operating system on which it would be running. So all of this comes under infrastructure. This is the job responsibility of DevOps engineer to create it. Then coming to application, how would the applications communicate with each other? How would the load balancing work? How, if a load comes on your website, how would you upscale it? How would you manage the load? All of those things again come under DevOps responsibilities. Not writing the code. I am again not saying that writing the code is DevOps engineer's responsibility, but how would the applications communicate with each other? That's his responsibility. How these applications would be deployed to this infrastructure, that's his responsibility. And then at the end, obviously monitoring your application, getting the logs of your application, that okay, your application is working fine or not. So for example, if at night 4 a.m. or 3 a.m. an error occurs, a bug occurs, or a downtime happened, how would you get to know that, okay, what happened because of which the downtime resulted? So how can you see that? That's with the help of logging, that with the help of observability, monitoring, that okay, if a server is 80% is using the CPU 80% or is using 80% memory, so how would I get to know? There should be alerts for it. If a server is using more than 80% of the memory, then an alert should be generated. So all of this comes again under the operations part. So this whole cycle is DevOps engineer's responsibility. And again, as I said, the DevOps is not an easy job. DevOps, again, we will see that DevOps engineers are one of the highest paid jobs. But why is it the one of the highest paid jobs? This diagram somewhat tells this, because you would be responsible for infrastructure. You would be responsible for application scaling. You would be responsible for operating, the monitoring, the logging, each and everything. If an error occurs at night 3 a.m., you would be the first one to be called upon to look into what happened, not the developers. Developers would be the last one to be called upon, because their task was to write code. And now that code is deployed. If it's not working, it is upon you. You are the owner of that infrastructure. So again, to reciprocate what I just said, why should we move to DevOps? Based on monetary funds, or basically monetary benefits. So this is a Google Trends. You can see that how DevOps in the last 10 years has gained popularity in the Google Trends. So this was March, and now you can see a total exponential sort of a gain after 2015. Because again, as I mentioned, that now downtime cannot be tolerated. 1 minute downtime means loss in billions. Your shares start falling. Your worth starts falling. You have to follow SLAs. You have to give fines if there is downtime in your app. For example, in the company that I work, as I mentioned, that we handle almost 3 million transactions in a week. In a week, we handle 3 million transactions. So in a day, that amounts to almost 0.5 or 0.35 million. So if our application is down for a day, we would miss that much of transactions. So now coming to the salary part. So this Stack Overflow, we all know what Stack Overflow is. All of us would have used it for finding answers for our questions. So Stack Overflow does a survey every year based on what technologies are popular, what languages are popular, the software languages are popular, which salaries, which fields has the highest salaries, or those things. So this is 2018. Germany, India, DevOps is the highest paid job. United Kingdom, United States, DevOps is the highest paid job, even above data scientist, even above full stack development. All of those things, DevOps job. 2019, India, Germany, again, DevOps is the highest paid job in 2019. United States, United Kingdom, DevOps is again above data engineer, data scientist, data backend engineer, mobile engineer, anything. 2020, engineering manager. Obviously, engineering manager managers are more paid, but site reliability engineer, again, site reliability engineer and DevOps are sort of the same, has the same job responsibilities. I am a site reliability engineer at my current company. They are sort of same. Obviously, there are differences between them, but I would not be going into that detail for today. And then DevOps, then data engineer, then other things. We all know about data science, we all know about data engineering, but most of us would not be knowing what DevOps is, what how or should we move to DevOps as a career path or not. So, but from here you can see that DevOps is the one of the highest paid jobs. Again, 2020 DevOps and site reliability engineering are the highest paid jobs. 2021, again, they are the highest paid jobs. So you can see that this trend keeps on following. Even 2022, I saw that it is again the highest paid job. I have not included that in the slides yet, but in 2022 survey, I again saw that it is one of the highest paid job. This is a Glassdoor survey about DevOps engineer salary. So an average DevOps engineer gets this, a senior DevOps engineer gets this almost per year, and a lead DevOps engineer gets this amount according to Glassdoor surveys. This is Pasha survey. Again, Pasha is the Pakistan Software Housing Authority. So this is their survey where in the senior level, obviously not in the junior level, in the senior level, game producers is one of the highest paid job, and then DevOps engineer is the second most highest paid job, even according to the Pasha survey. Again, it is one of the hardest jobs to fill. That's why it is the most paid job, because obviously if the recruiters are not able to find good people, then they would be willing to even pay more for a person. So these are 3 different blogs. All the references are over here, which says that DevOps would be the hardest job to fill in 2021, DevOps position to be the hardest to fill, DevOps engineer, number 1 hardest job to fill. So that's why obviously if a company is not able to find a good DevOps resource, then the company would be willing to pay even more for a good one. Then there were recent acquisitions. Microsoft acquired GitHub, IBM acquired Red Hat, Mirantis acquired Docker. Docker is, again, most of you might have heard about it. It's what runs containers or ships containers and those things. So how to become a DevOps hacker man, or how to you can move towards a DevOps field? Again, coming back to the same diagram, that what your job responsibilities would be: infrastructure, applications, operations, all of this would be your responsibility. So how we would be fulfilling this responsibility? First is infrastructure as code. So previously what happened was there were ops engineers who used to create infrastructure manually. So for example, if you are on cloud, you would have to go and create a server manually and do those things. But if you are a DevOps engineer, you would be creating the infrastructure through code. There are different tools for it, Terraform, Ansible, and those things. So you would be doing that. So what is infrastructure as code? You need infrastructure to deploy your applications. Again, as I mentioned, that this is the core part where your applications will get deployed, and then you will monitor your application. So that can be on-prem or on cloud. On-prem, what happens is, for some of the beginners, what on-prem actually means is that you have a local data center, you have a local server where your apps are running. So why is it necessary? Because of data laws. So for example, NADRA has a law that NADRA's data cannot leave Pakistan's premises. For example, I cannot host NADRA's data in a US server, or in a, for example, Europe-based server. I cannot host it. I can be legally challenged, or legally I can be held accountable for it if I have an application which hosts NADRA data outside Pakistan premises. So obviously, if that is the situation, I need to have a server in Pakistan. And there are no major clouds in Pakistan. There is no AWS, no Google Cloud, no Microsoft Azure, no Alibaba, no basic Oracle Cloud or IBM Cloud. No cloud is major cloud is there. Nayatel has some clouds over here. So either you use that or you manage your local infrastructure. So that is what is meant by on-prem servers. Then there are cloud servers. So for example, I buy a server on cloud on AWS and I deploy my application there, or I buy a cloud server on Azure or Google Cloud and I deploy my application over there. So that would mean a cloud deployment. What cloud actually means, again, I will tell it in a bit detail, but that what's mean that the infrastructure can be on-prem or on cloud. Then the next question is how to create hundreds of VMs or thousands of VMs. If you want to create an infrastructure, obviously the production environments don't get deployed on one server, because the production applications, the heavy applications, they are reliant on many servers, or they need many compute. So you need to deploy hundreds of VMs. Then infrastructure and servers can quickly be created or recreated using standardized pattern. So again, the main point is to create infrastructure which can be reproduced easily, which can be recreated easily, which can be scaled easily. If you have manual intervention, so for example, as of now, if I go to AWS console and create one server manually, it would ask me around 10 to 15 questions that I have to select from. That, okay, what is the instance type, what is the storage, what is the RAM, what are those things. So obviously I would have to select each and everything. And if I have to create hundreds of VMs, then for each VM I have to select that manually. And then if I have done a mistake in selecting the storage or selecting the RAM, then I have to go for hundreds of VMs again and edit them. So in code, what you can do, you can just change that line and apply it again. It would run irrespective of there are hundreds VMs or thousands or 10,000. It would run in just a minute or two and would change all of the infrastructure. Now the next thing, obviously, these are your servers. You need Git installed on them. You need Jenkins, or you need a database installed on them. And you have hundreds of VMs. So for example, there are 10 VMs that need Git installed. How would you do that? If you are doing it manually, then obviously you have to go into each server and install Git manually. But what Ansible does is it helps you to deploy any software on any number of instances on just one command. So Ansible is again an infrastructure tool which is quite popular. Terraform is used to provision, is used to install softwares on that server or change that server somehow. Recreation of, so the main benefits of basically infrastructure as code are recreation of environment. Again, if you have to recreate an environment, hundreds of VMs, if it's done manually, it would take days to recreate it. Deploy everything in an automated way. Main purpose is to have state and deployment manifests, and these are some tools for it. Then again, one of the best practices of DevOps is to provision through cloud computing, to provision resources on cloud. Now, no one prefers to have local servers. Only if you have a data law, or if you have sensitive data in your application, then obviously you would need to have your local servers. But if that's not the case, you can easily handle that on cloud. So what cloud is, actually, it gives you an on-demand computing resources. So if I need a server on cloud, for example, 8 GB RAM, 16 GB RAM, or 32 GB RAM, whatever I need, I can rent it on cloud on AWS. AWS will give me a server which will have 16 GB of RAM, for example. I can deploy my application there, and my application would start running, and basically whatever I want from that application. I don't have to buy resources. I would be renting the resources. Elastic resources, again, if there is load, I can easily scale them up or scale them down whenever I want. Pay for what you use only. So if I rent that server for 3 hours, I would have to pay for 3 hours only, not more than that. Self-service, again, there is clouds have their own consoles. You go on that cloud, you click a button, and you can provision a server for yourself. There are different models for clouds on premise. Someone is unmuted, I believe. So On premises, you have to manage everything. So the blue part is you manage, and the orange part is what the cloud manages. On premise, you have to manage everything yourself. So if the server goes down, you are responsible for it. If the networking goes down, you are responsible for it. If you buy it on cloud, now if the server goes down, the cloud would be responsible for it, and cloud would recreate it, or cloud would re-provision it itself. You would be responsible to select an OS. So for example, I need a Ubuntu OS, I need a Red Hat Enterprise Linux OS, or I need a Windows OS, I need Java installed on it, and my application. So these things I will be managing, and these all things will be coming from cloud. Then comes platform as a service. So for example, again, I have a Python application. So the server would also be provisioned by cloud, and Python would also be installed on that cloud. Obviously, I would select the version, or I would select the runtime or OS. That thing I will select, but that will be provisioned by cloud. And to make it sure that they keep up or maintain the uptime, that is the responsibility of the cloud. I will just put in my application or copy my application in it, and it will start running. So this is a platform as a service. Then comes software as a service. So for example, Facebook is a software as a service, which it's giving you that, okay, you can come and interact with your friends. That's a software as a service model. Again, infrastructure as a service, different servers that you can buy on cloud. Platform as a service, where you can deploy your applications. And software as a service, for example, Google Docs, Facebook, Office 365, all of these are softwares as a service. And then there is a serverless model, which is also gaining quite popularity. What it actually means is that you can run a function in cloud. So if you are if you know the OOP concept, the object-oriented programming concept, so now what you can do is you can write a function and you can host it in the cloud, and then it will automatically run whenever you call that function. So now the functions would be deployed on cloud. If load comes, scaling it up, scaling it down, all the responsibility lies with the cloud provider. You would not have to do anything. That's why it's known as serverless model. Obviously, every software would need a server to run on, but you would not be managing that server. Now the cloud would be managing that server. So that's why it's known as serverless, because for me, it actually is serverless. Cloud would be handling that server. So there are a lot of clouds: Google Cloud, AWS, Azure, Oracle Cloud, IBM, DigitalOcean, OpenStack, and again, a lot of other clouds as well. So again, why DevOps is one of the most difficult jobs, because there are so many options when it comes to clouds, or when it comes to each and every technology. So one company might be working on AWS, other would be working on Azure, the third would be working on Google Cloud. So you would have to have experience with all the major clouds, or you would have to work with any of them in the future. Even if you are not an expert, but you might have to work with any of them in the future. Then comes a microservices based principle. So previously, just to explain you what microservice means is, previously what happened was that there, for example, this is an e-commerce website. So this is one website which will have all the logic for your application: accounts, orders, promotions, inventory, products. There would be one data access layer and one UI layer. But this approach is quite bad, because, for example, again, the example of Daraz. So on a 11th November sale, if there are a lot of customers coming to the Daraz page like me, so for example, what I would do, I would go to the Daraz page and would see the products and see if they suit me or not, and then I might buy or I might not buy. And 90% is the case that I might not buy. I would just be window shopping. And there would be a lot of millions of others like me that would just be doing window shopping. So the major load would be on the product's code. So basically, again and again, the products would be loading. Accounts and orders would not be under load, because out of million, only, let's say, 10,000 people would log in and actually buy anything. But the other remaining customers, they would only be using the products code, they would not be ordering anything. So what microservices says is that if there is such a case, you can divide the one service, this is one service actually, which is divided into multiple microservices, small services, which will have their independent logic in them. So now what will happen is that product service will only be serving products. So when again you launch a sale and there are customers which will only be doing window shopping, so the load would only be on the product service. The account service would not be affected by this. The order service would not be affected by the load. Only this would be affected, the product service, and which you can scale up individually. You can scale this service individually irrespective of this, because the load is only on this service. So this is a microservices based approach, and each of them will have its own database. Each of them can have their own language. So for example, this can be written in Python, this can be written in Java, this can be written in any language, Go language, for example. This can use a MongoDB, this can use a Postgres DB, this can use any other DB, MySQL DB, for example. So that's the benefits of microservices, what that you will have independent services communicating with each other through APIs. They will be calling their APIs and would be getting the response. So previously they were calling the code. This was one service, one big service having all the code inside it. Now we divided it into multiple microservices, with each having their own database, each having their own logic in that service. So one of the biggest companies, Netflix, Twitter, Hail, Amazon, they have thousands of microservices or hundreds of microservices running, and they serve the content through that microservices. So that's how easily scalable their infrastructure is, that Netflix never goes down, or Amazon, they never go down. Why? Even if there is a sale or not, even if there is high load or not, because they would only have to scale that application which is actually getting the load. And when you say about microservices, containers become necessary. Containers are sort of synonymous with microservices. If you are having a microservices based architecture, then you would be needing Docker containers or containers basically. So that is sort of necessary when it comes to microservices. So whenever if a company is working on microservices, they would be needing containers for it. And Kubernetes again is what I should say, that is the advanced version of how to run containers in a better way, in a productionized way. So again, this is one company, how they transited. What they did was they had a monolithic application. They basically transit to microservices based model. They deployed it into containers for their each microservice, and then they deployed it on Kubernetes using that containers. Obviously, you would not be knowing containers and Kubernetes in detail for now. But we in our course, obviously we cover all of these things in very detail, and you would get to know that, okay, what container is and what benefit actually it provides, and why microservices are always deployed in containers. This is the Kubernetes adoption in 2020, that 83% of the companies used Kubernetes for containers orchestration, and 92% companies basically were using containers in production. So this is a public survey again that was done, and these are huge numbers, which actually means that 83% of the companies were using Kubernetes to deploy their applications in production environments. So for example, in the future, this number will grow to 90%. And if you as a DevOps engineer, or if you as a developer don't know Kubernetes, then obviously that's a huge loss for you, because majority of the companies would be finding resources that are having experience in Kubernetes. Again, this is a Red Hat survey. Red Hat again is one of the biggest companies when it comes to DevOps fields. They have a competitor of Kubernetes, basically OpenShift. So they also did a survey, and 88% companies were using Kubernetes for container orchestration, and out of which 74% were using it in production. So their production environment workloads were deployed on Kubernetes. Obviously, 88% would mean that some were still testing, some were trying to or thinking to move to Kubernetes, but not now. They might move it in the future. And when you come to microservices based architecture, then obviously you need a lot of tools to understand, because again, it will be your job responsibility. Again, if I show you this, so this will be your job responsibility to handle the load balancing, to handle the inter-service communication. If, for example, there are multiple microservices, how will they communicate with each other? How will you store the containers? How will the service discovery, but how will the scheduler, the orchestration work? So these are all your job responsibilities, which are difficult in the microservice-based architecture. There are API gateways that you need to understand that what they do. There are messaging queues, Kafka, RabbitMQ, Amazon Simple Queue Service. Kubernetes again has a lot of offerings. Docker containers, there are a lot of companies that offer container orchestration and containers, what container actually means, server mesh and serverless model. So again, these are all different tech tools and technologies that you need to understand that how they work if you want to move towards a DevOps career path, and the companies that you go to use microservices. And again, microservice is the default way to work in today's age. Then comes CI CD. So again, you might have heard about it, CI CD, continuous integration and continuous delivery or deployment. So now what it means is that you have the infrastructure, you have the applications running on top of it, but now you need to deploy a new feature. So the previous two things, what they actually meant was that now your application infrastructure is created. Your, if I go back just a second, your infrastructure is there, your application is deployed on the infrastructure, but now when a new image comes or a new feature comes for your application, how will you deploy it? How will the continuous feedback process work that we were talking about previously? How will that whole process work now? So that is continuous integration and continuous delivery or continuous deployment. So continuous integration, as the word says, so obviously when you will be working in a company, there would be a version control system like GitHub or GitLab or Bitbucket. You might have heard about these names. So these are different softwares basically where you host your code, where you keep your code, the code base for your application, and you basically interact with different developers and work on the same feature. And whenever you push your code, so for example, you pushed a new feature, you have a new feature, the development is complete, you pushed it, and that started. Now you want to deploy it. So what CI would mean is, so for example, over here, this was it, you pushed your code, unit tests started running. So what unit tests mean is that they check your code, whether your code is fine or not. Writing unit test is not a DevOps engineer job responsibility again. Writing unit test is the responsibility of the developer himself. As a DevOps engineer, you would not write unit tests, but you would be responsible for running those unit tests in the CI pipeline. So whenever a code is pushed, as I said, that what DevOps actually means is to take the code from developer, test it, check if it's error-free, it's correct, then deploy it to prod or any other environment. So what that means is to how to check whether that code is correct or not. So obviously, you need to run some tests on that code and see whether that code is correct or not. Do some code analysis, do the test coverage and those things, and then you can release it on any environment. So this is a CI infrastructure or a CI model. Then comes continuous delivery. So now your code is merged. Now your code is basically deployed. What CD says, rather, let me show you this. continuous delivery and continuous deployment. So what over here means is that you can deploy your application up to a pre-prod environment automated way, in an automated way. But in continuous deployment, as the word suggests, deployment, you even deploy it to the production environment in an automated way. So for example, a new feature is added. That new feature will now get deployed to a pre-prod environment, to a staging environment, for example. Our integration tests would run, end-to-end tests would run. Again, now those tests are the responsibility of a QA engineer to write, but your responsibility is to run those basically tests in the pipeline. That pipeline will run, and if that pipeline passes, now you can deploy it to production environment. So this is continuous delivery and this is continuous deployment if it's automated. So for example, you deployed it to staging, automated test ran, and you deployed it to production in an automated way. But over here, the deployment to production is manual. So that's the difference between continuous delivery and continuous deployment. So again, our purpose was that whenever a new feature is pushed by the developer, we will run some tests on that code. If that code is correct, we will deploy it to production. If that code is not correct, we will tell the developer that, okay, this test failed. This test failed because of this line of code. Now the developer will fix it. So that's what continuous CI/CD actually means, to keep running the pipelines, to keep testing your code, whether it's fine or not, and then deploy it to production, so that there is no manual check left there and there's no manual chance of a fault there. And again, if you have CI/CD for a monolithic application versus a microservices-based application, so if over here a team B was working on some software, team A, C, and D are done, their code is error-free, the pipeline passed, the end-to-end test passed, but team B was working on a feature which is not yet completed, so you cannot release it to production. You cannot release this software to production because the team B still hasn't fixed their errors. So that's the issue with monolithic application. Whereas in microservices-based application, if the team B has not completed their or fixed their issues, their release will not go to production, but other teams' releases will go to production. So over here, if I show you the example over here again. So for example, inventory service team wasn't able to fulfill or pass the tests or whatever. So their newer version will not get released, but account service will get released. So I had a new feature, for example, where in accounts something new was shown or a UI was changed or anything. So now I would be able to see that, but inventory change would still not be there. So again, that's a huge achievement when you tell about when you compare it with monolithic based architecture. So over here, if one team was not able to work it, the whole release would not go to production. Over here, if one team was not able to fix it, only that service, microservice, would not be released. Other microservices would be released to production. Then there are different CI/CD tools. Again, CI/CD means writing a pipeline for it. Whenever the code is committed, whenever the code is pushed, the new feature is pushed, a pipeline will run, which will do all of these steps that I mentioned over here. A pipeline will run. That will be an automated pipeline that will run and do all the above things. So there are GitHub, GitLab, Bitbucket. Obviously, you need to have understanding of how a version control system works. You need Jenkins, GitHub Actions, GitLab CI. So there are a lot of tools for this part. Let me just go to questions if there are any. In this session, what will the agenda like DevOps hands-on on some tool? In this session, obviously, this is just a webinar, but there would be no hands-on in this webinar. This is just a 2 hours basically webinar. But in the course, we have around 60 to 70% of hands-on in the course that we offer. So all of these tools and technologies that we are currently learning about, there would be detailed theory about them, and then there would be proper labs and proper assignments, proper project for all of these things. Why does it has to be reviewed by customer only? Why not QA team? So Nimra, basically what I was trying to say is that is the end part. That is the end part, that when your application is deployed to production, then you will obviously be getting the feedback from customer. From QA, that is an internal thing that will obviously come before that, before deploying to production. That is the internal things. That is the pre-prod testing that I mentioned. The pre-prod testing that you will do before deploying it to production. The QA is your internal team. So obviously that is a pre-prod testing. But once a software is released to production, now obviously your actual customers will review it. So for example, Facebook releases a new software. I am a customer of Facebook. When they will release a new software, I would be able to see that. But before releasing a software, obviously Facebook does a lot of tests. There are a lot of pre-prod environments, dev.facebook or qa.facebook or whatever pre-prod environments they have. So all of those will run before deploying it to production. And those will obviously be reviewed by their QA team or by their internal teams. So there is no sprint concept in DevOps. Again, as I mentioned, no, there is sprint concept in DevOps. You would be working on it, but it's not compulsory that you will release all of your software only after the end of the sprint. You can release it whenever you seem that your code is correct, you can release it. Can we get these links or slides? Yeah, I believe you will get these slides. You can contact DICE after the webinar. So it means DevOps engineer should have some knowledge of dev, test, and ops, etc. Yeah, so he should have a basic knowledge of development, how development works, how development life cycle works, software delivery life cycle, basically how it works. Testing, no, he shouldn't know about testing. Again, as I mentioned, that these tests would be written by the QA guys. Your job responsibility is just to run these tests. They are written by anyone else. The code is written by anyone else. Your job responsibility is to deploy that code. Your job responsibility is to run those tests on that deployed code and share the results that, okay, if it went fine, okay, that's good. If it did not work fine, share it with the developer that, okay, this is the issue with your code, please fix it. If it's scalable, should it always be cloud-based? No. There are on-prem scalable things as well, but obviously that also means to have a cloud-based sort of an environment, OpenStack, or those things which basically allow you to run on-prem servers in the form of with the help of cloud. But yeah, so for example, I have a server on my local on-prem, and now today the load is getting high. So for example, my server is using 80% memory. On-prem, what we would need to do is we would need to buy a new server. I would have to go to the market. I have to buy a server, connect it with my on-prem data center, and then this will be scalable. But obviously, this is not scalable, not a comprehensive scalable architecture, as you can see, because I have to go buy a server only for today. And as I mentioned, Draz, so for example, Draz has a sale. So only for that day, that second server would be used. But other days, that server won't be used because there is not enough load. But if you are on cloud, obviously, you can just rent a new server for that day. Once the load gets down, you can again delete that server from your cloud, and you would not be paying for it. So in cloud, you always pay by hour. So how many hours you use a server, you would pay for that. Do we need to require any previous programming, networking, or DB knowledge? So yeah, I will come to it at the end, that what is the roadmap if you want to get into DevOps. But yeah, I personally believe that a basic programming concepts would help you a lot if you are thinking to move into DevOps. At least scripting, at least a basic knowledge of if I show you a code, you are able to understand that what's happening in it. This is easy for a fresh graduate. This is, I would not say easy, but obviously this is a bit difficult. And one thing that I would like to clarify over here as well, that DevOps, as I said, is a difficult field, and a DevOps engineer has a lot on stake. Basically, he has a lot of responsibility to cater for, because he is the one handling the production environment. If the production environment goes down, you would be responsible for it. So many companies, they mostly go for experienced candidates for DevOps. But how you can gain experience, because obviously you need experience to you need a job for experience, and the job needs an experienced guy. So this is a cycle that always happens. But such courses, because in this course we have hands-on practices, hands-on labs, we have assignments, we have an actual project where you would be working with microservices, CI/CD tools, containers, Kubernetes, all of these things. So that can help you if you are thinking to move towards this field. How can be things too much independent? They can be. Obviously, a little bit of dependency would obviously be there. I'm not saying that there's in theory, obviously microservices say that they should be independent, but in practical deployments, that's not the case. There is a little bit dependency, but Dinesh, maybe you're annotating something. So, but still, there would be a little bit of dependency on things over there. How would you differentiate backend and DevOps guy? How much it is necessary backend experience before shifting towards DevOps? So backend is again a developer job. He would be writing the code. DevOps guy is a totally different job. He would be deploying the code. So they are two different job responsibilities. Isn't it mostly the responsibility of devs now for releasing their code to the customers? No, I would say no. Some companies, obviously, they try to enforce it, that the devs are responsible for it. But I have a huge debate with many people on this topic, that aren't devs responsible for DevOps? So as I mentioned over here, that there are hundreds of tools over here that I have told you till now. How can a developer basically read about each of them and then write the code as well? How can he be handling the cloud as well as knowing how to code? How can he understand Kubernetes and then understanding the code as well? So basically what happens is that companies try this model, what you said. The companies do try this model that devs are responsible for deploying the code, but they fail because the devs, they don't know Kubernetes. They don't understand how complex Kubernetes is, and they just try to deploy the app in a very basic way, which is never the better way, or which is never the best way. And even as I said, that I am a consultant at many places. So what happened was they tried the same methodology, and at the end they had to bring in a DevOps guy to fix all of those issues that were happening, because the dev had deployed it, because he didn't understood the tool completely. He didn't understand the security perspective of all of these things. And then after that, you have to bring in a DevOps guy to fix all of those things. What if the different microservices have something in common and can't be deployed to prod because the other microservice has not passed its test cases? Yeah, if they have the dependency between them. So for example, if one microservices calls the other microservice and the other microservice is actually not working, is not running fine, then obviously you have a dependency case. As I mentioned, that in theory, microservices principle says that there should be no dependency. But when you come to practical deployments, obviously there is a bit of dependency between each of them. And this issue can come over there. Can we add or perform our own customer lab scenarios during the actual sessions? Yes, mostly yes, because we would be guiding you. Everything we would be doing on local. So again, just to clarify, this course does not cover cloud. We would not be doing anything on the cloud. We would be doing everything on our own laptops, on our own test, either VM. We would be using it on a Linux VM, and basically handling those things. So you would be doing all the labs yourself. You would be provided with labs. You would be provided with commands, how to run those labs, and everything. You would be doing that. But in this session, obviously, this webinar, this is just for 2 hours, and there would be no hands-on lab at the end of it. How often does operation issue arise in prod and after DevOps era? How often do you get calls at 3 a.m.? Now code is gone through DevOps. Again, this is a myth that a code can be error-free. This is a myth. A software can never be error-free, even if you have DevOps, even if you don't have DevOps. What DevOps does is that you can basically check those errors in the pre-prod stage, not in the production stage. If in a pre-prod stage you find 80% of the errors that previously were going to prod environment, that's a big win for you. Still we get some errors, still we get some downtime. Facebook, one of the biggest companies, one of the best engineers, had a 2 to 3 hour downtime. So again, you cannot say that this company is one of the best DevOps company and they would never get downtime. That's never the case with software. In software, everything will go wrong if you think about it. Difference between Terraform and CloudFormation. So Terraform is a bigger tool. You can have multiple providers with it, even Azure, Google Cloud, or anything. CloudFormation is just for AWS. So CloudFormation, you can only deploy infrastructure on AWS. Sorry to ask a relevant question, but I joined the webinar. Sir, I have 3 years experience and working as senior software engineer. Should I go with DevOps in parallel? Yeah, I will recommend, because as I mentioned that companies are looking for software engineers who have experience with Kubernetes, who have experience with DevOps technologies, so they can work with those tools as well. Sir, I believe at your time of graduation, DevOps was not taught at bachelor's or master's level. Then how did you get your way? Even I believe now DevOps is not taught in any university. I have had different sessions into universities, and genuinely the universities are not teaching these so popular, I would say, technology. I don't know why, maybe because they don't handle these things themselves. But yeah, what I did was I went into Bentley Systems as a software engineer. I worked there for 2 years, and fortunately we got a project to deploy everything on cloud, to move from a monolithic based architecture to a microservice based architecture, and use containers and Kubernetes. So that's how I provisioned my way into DevOps, and I started learning about containers, Kubernetes, and those things. So this I'm talking about 2017. So I am working on Kubernetes from past 5 years, and Kubernetes was released in 2014. So I am working on Kubernetes from 2017. So personally, I have enough experience in Kubernetes and those things. But yeah, you are right that our institutes, they don't teach DevOps at this level. Maybe they don't have enough resources to teach those things or whatever. I am not sure, but I have given talks and universities to basically preach this at their level. If you are following microservice, you must have your own servers. We cannot deploy to AWS or cloud prod environment using Docker Kubernetes. We can deploy. That's what I said, that you can deploy to production environments using Docker containers and Kubernetes. But obviously at cloud, you would be renting a server and then deploying it on that cloud. It does not happen that there is one server and everyone deploys their software there. Obviously, you will rent a server on the cloud and then deploy your software on the cloud. How this course will help in getting a job? I see most jobs require a lot of experience. So yeah, I have answered that already, that yeah, experience, most companies ask for experience when in a job description when it comes to DevOps. But having no knowledge of what DevOps tools is compared to having or completing a full-fledged project, an industry related project or industry level project in a course and taught, obviously that creates a difference, and my students have gotten into jobs. As I mentioned that I have trained almost I would say 500 people, out of which 200 were related only specific to DevOps. What is the first step to move toward basically what is the starting point? Again, I will tell you this and then that how what are the requirements, and if you want to, even I have told you that basic programming, Linux. Do you offer job placement interviews? I see DICE offers interviews with companies for testing courses. Unfortunately, no. I can refer you to companies. I have referred many of my students, but I cannot say that I will get you a complete interview at a company, because I myself work remotely for a UK based company, so they have no office here. I am the only employee from Pakistan, rather from Asia. I am the only employee that works there. So I cannot get you an interview at my company, obviously, because we have already a team of DevOps. But yeah, over here, many companies ask me for referrals, and I pass my top students' resumes over there. But that I can do. Is DevOps only used for maintaining the software? If no, how can we use DevOps for developing a new software? And that is the best way to do so. So yeah, again, it is for developing new and maintaining old. So the developer would be writing new code, and the DevOps would be deploying that code. Okay, where we will find this recorded? I believe this is being streamed live as well, so you can see at YouTube or anything. I am a full stack. Okay, I will just go back to the course content and then might come back to questions after some time. Okay, so this was again coming back to the main diagram, just to show you that again what's the responsibility. So infrastructure that we have created through Terraform, that we have created in the form of code, applications, we have deployed them, we have containerized them, we have deployed them onto cloud environment, we have deployed them onto Kubernetes and those things. Now comes how we will operate on those applications. If an application goes down, how should we operate on it, how an alert would be generated, how we will work on it, and how we will act upon that alert in an automated way or whatever. So that is about monitoring, logging, tracing, and those things. So deploying infrastructure is not an issue. Again, this is not an issue. That is what ops guy can also do. That is what manual things can also do. But maintaining an infrastructure is one of the biggest issues. You will be responsible when infrastructure is throttled, network went down, machines are not working. So you as a DevOps engineer would be asked to fix all of this. So what you can do is there is again a lot of tools and technologies that you can deploy to monitor and see the logs sent by application. You can have active monitoring to ensure 24/7 availability. If an app goes down, an alert is generated. If a server's 80% memory is being used, an alert is generated and you act upon that. So in our practices, what we do is that we have monitoring in place. And whenever a server goes down or whenever a server has 80% memory usage or anything, we get a message on our Slack channel and we then work upon it and we then basically work it. So that's not the case that you will only be looking at dashboards and working on those dashboards. That's not the case with DevOps. Again, DevOps is about automation. Ops guy, previously the infra ops guy, what they used to do, they used to have dashboards and just keep looking at dashboards for the whole day and see if any error occurs. But you as a DevOps engineer will automate all of this, that whenever an error occurs, if the app goes down, if the pipeline fails, if the server goes down, if the infrastructure goes down, an alert is generated into a company-wide discussion channel, central place, so that teams can see logs of their application. Again, you collect all the logs for your applications and deploy it onto a centralized place where you can see the logs. Teams can monitor their application stats. Tracing mean how much time is spent and where it is spent. So when we say about monitoring, so this is how monitoring and logging works. So these are your microservices. There is a central monitoring tool which will be monitoring these microservices, which will be gathering the stats from them. This is the logging application which will be gathering all the logs from these applications and storing it. So if this app goes down, for example, at 3 a.m. in the night, I can go to this tool and see the logs of this application, that what happened at 3 a.m. in the night. Or if a server goes down, I can go at the monitoring tool and see that, okay, why did this server go down? Was there a memory issue? Was there a CPU issue? Was there a networking issue? So I can do that using these tools. Again, listen, this is one of, you can say, a funny thing, but this is actually true. Because previously, as I mentioned, there were blame shifting. The devs blamed the shift on the QA guys, or the ops guy blamed the shift to the dev guy. But now if you have a proper logging and monitoring in place, you can easily trace out that what was the actual issue. Because obviously if the app goes down, it would have logged something. You can go and see the log that, okay, what happened at that time? If the server went down, you can go and see the monitoring of that, and then you can obviously get to the actual endpoint, that, okay, what happened, rather than just blaming the shift on each and everyone. How can, and again, as I mentioned, that DevOps is not about you will not have any downtime. DevOps is about not to have a similar downtime in the future. So if you have a downtime today and again you have a tomorrow or on any other day, that's a failure of you as a DevOps engineer. But having one downtime, that is not your failure. Having repeated downtimes due to the same reason, that is your failure. Because if you saw a downtime, you should automate it and try to fix that, that this should not have released into production environment. This should not have released into production. Why? How did this happen? So if there is a downtime due to a new reason, then that's acceptable. But as a DevOps engineer, this would be your failure if a downtime occurs again due to the same reason. Then again, there are a lot of tools for monitoring, logging. There are managed cloud solutions, Prometheus, Grafana. These are one of the most popular tools, open source tools. Nagios, Datadog, Jaeger. Again, a lot of list goes on. And if you see, for example, 10 job descriptions of a DevOps engineer job post, you will see that some would have mentioned Prometheus, Grafana, some would have mentioned Nagios, some would have mentioned Splunk. Some would have mentioned ELK or any of such tools. So there is a lot of technology diversification in DevOps because every company has its own set of tools. Some would be working on AWS, so they might be using managed solutions. Some would be working on Azure, so they will have their completely separate Azure technology, Microsoft technology. So this is what you have to face on a daily basis when you are a DevOps engineer. And the last thing, obviously, communication and feedback. The DevOps originated because there were communication issues between developers and operations and those things. So DevOps actually means to have a open culture in your company. If there is an error, you accept it. If there is an error in infrastructure or in DevOps, you accept it. And rather you accept it, you have an automated alert for it. So for example, if I tell you my personal things, so for example, there is an issue in infrastructure that I am responsible for. If there is good automation, alert would be generated and it would be sent to Slack channel. I am not able to stop that alert. If that alert goes to the Slack channel, whole company would be able to see it. The developers would be able to see it and they can plan accordingly. What DevOps engineer or what a poor DevOps engineer or what an ops engineer, what he would do is he would not show his alerts. So for example, if the feature is correct, you get it deployed and take feedback from the customer. If issue is in code, you give feedback to the developer that, okay, your code is wrong. If issue in infrastructure, communicate to teams as soon as possible. So DevOps engineer or poor DevOps engineer or an ops engineer, he would not do this stuff because he would not have automation. He would not have automation, so he will skip this part. But if you have automation, automation would not care whether it's Ali Kahoot making a mistake or it's a developer making a mistake or it's anyone else, and that alert would be sent there. That's not to hold anyone responsible, rather to actually work on the betterment of your infrastructure in the future. So communication and feedback is one of the major players or major tools when it comes to DevOps or alerting. The alerts that I mentioned, that alerts should come to a public channel that where anyone can see, okay, what went down or what happened. So again, there are Slack, Teams, Microsoft Teams, basically Jira, Alert Manager. There are different tools for those things. And then again, there are companies that would say that we are doing DevOps, but they won't have agile methodologies, they won't have stand-ups, they won't have CI/CD or any of those things. So obviously that's not DevOps. If you say you are doing DevOps without these technologies, that's just a joke in itself, because DevOps is based on agile methodology. DevOps is a cultural thing as well, that you open your culture as a company that, okay, downtimes will occur, that, okay, developers will make mistakes, but you improve on them and you automate all of those things. Again, the summary, as I mentioned, plan, code, build. So this part would again come into CI/CD, coding, building, testing, releasing, deploying, and operating. This will come again under the Kubernetes part, containerized part, CI/CD part, monitoring and operating. This will come under monitoring, logging, those things. And these are, again, as I mentioned, a lot of tools doing the same things. So in our course, we cover Git, we cover GitHub, we cover Jenkins, we cover GitHub Actions for the CI/CD part, we cover Docker, we cover Kubernetes, we cover Terraform to create the infrastructure, we cover Ansible. So all of these tools, Docker Compose, so all of these tools are covered as part of course. Monitoring is not part of this course. We don't, because that's an advanced topic. Once you get to know the basics, then obviously you can move to the advanced things. Summary, just to sum it up, so CI/CD release once a week, higher quality of code, microservices, loosely coupled components deployed in automated way. So again, having separate services for each deployable application, responsibility, shared responsibility, common goals. Again, the purpose of DevOps was to have a shared responsibility. And infrastructure, you can have cloud, containers, Kubernetes, build once, run anywhere. So again, Kubernetes is one of the more, why it is one of the most popular tools, because it is build once, run anywhere. So I can build or I can deploy my application on Kubernetes on an AWS cluster. Then I can move that to a Google cluster. Then I can move that to an Azure cluster. I would not have to change a single line of code. So that's why Kubernetes is one of the most popular tools. And now coming to the DevOps technologies or roadmap, if you want. So programming knowledge, you should have at least basic scripting, Linux, networking basic, that okay, how does networking works? How does two servers communicate with each other? What are IPs? What are IP CIDRs? Those things are basics about networking. When I type google.com, so how does that actually work? So you should have a basic understanding of that. Git, again, this we cover quite in detail. Linux, we also cover basically Docker containers, CI/CD tools. There are a lot of tools for it. Jenkins, one of the most popular. GitHub Actions is also one tool. So we cover both of them in this course. Knowledge of clouds. We don't cover clouds. I just give a basic understanding of clouds, and what it works, and do some Terraform labs on cloud. Basically, for Terraform, we need infrastructure to provision. So we use cloud. I have a personal AWS account that we use for this, for the labs, Kubernetes, Terraform, Ansible. And so these are the major roadmap if you want to follow, and if you want to move towards a DevOps based or career. And for a DevOps engineer summary, I will say be tool independent. As I already mentioned, that for each technology, there are a lot of tools. There are 10 to 12 tools for doing one thing only. For CI/CD, there are 10 to 12 tools. For monitoring, there are 5 to 6 tools. For clouds, there are 7 to 8 major clouds. So be tool independent, but have expertise in at least one of them. So you have, for example, expertise in AWS, and you don't know Azure, that's okay. But be open to learning that. Be open to changing that. Be adaptable. So that is again one of the major things, that you be adaptable to change to new technologies and to new basically tools and technology. Because again, as I mentioned, that there would be a lot of opportunities for you to work on different tools. One company would be working on one tool, the other company would be working on any other tool. You should be adaptable to that. Development experience, obviously, being having or understanding of how development works, how the development life cycle works, all of these things would be quite beneficial for you. And able to learn and unlearn, that is one of the most, I would say, best advice that I can give you. Because what happened was, or what even happens now, that managers or people that are senior, they just learn one tool or technology and then they don't move away from that, or they don't try to learn any other technologies. If there was a person who learned Java 15 years ago, he would still be working on Java or any such tool. So if there is a new tool in the market, new application in the market, you should learn the new tool and unlearn the previous tool that is now obsolete. Don't try to stick with it. In DevOps, every day a new tool is coming. Every day a new technology is coming. So you have to be able to learn the new technologies and unlearn the previous technologies. So that is, I would say, the biggest advice that I can give you, because in our field, every day a new change is coming, every day a new tool is coming, not just in DevOps, even in software development. I would say there are a lot of fields now there, React.js, even in front-end development, there are 10 to 12 frameworks. In back-end development, there are newer changes coming every day. So try to focus on this and try to learn the new technologies rather than sticking by old technologies, because they will become obsolete one day. Yeah. Okay. So that's it from my side. Coming back to the questions, DevOps training. Yeah. What should be the best skill to learn for a beginner looking for a career in CS? So yeah, these are the tools that I mentioned. So these are all the tools. Most of these we cover in the course already. Sir, how important is DevOps considered in Pakistan software industry? It is considered. Pakistan unfortunately moves a bit slower. So DevOps gained popularity around 5 years ago worldwide, but now Pakistan is gaining popularity. Now I know Mobilink, Telenor, Zong, they are trying to move towards containers. I personally know them. They reached out to me, or I have friends working there. They are trying to move to containers and those things. But as we lag behind in a lot of things, so but now they are moving. But still, I would say that relatively in Pakistan, DevOps is still lags behind as compared to worldwide, because in Pakistan we do not have product-based companies that much. To be honest, we don't have that much product-based companies. We have service-based companies. We build websites for others. We build mobile applications for others. So that's why we don't focus that, okay, we should try to do it in a better way. We just think that, okay, let's move on with it. Let's deploy a website, however that's deployed, however that's working. We just need a working website for our customer, and we give it to him. Then he is responsible for how to manage that in the future. So that is one thing that Pakistan, we don't have that much product-based companies. Can you provide one-on-one training session? No, sorry, I don't provide one-on-one training session, because obviously that takes a lot of my time. Can we do freelancing after your course? Obviously, that depends on you. I can assure you that what tools and technologies I have mentioned on the course content part, I will cover each and everything of that. You can see that whether there is a freelancing scope for that thing or not. Obviously, that depends on you. I would not be forcing you that you cannot do freelance. That depends on you. I thought DevOps was about CI/CD creation for cloud. It's not just that. That is my thing. Cloud is a sub part of DevOps. DevOps is a very major field. Cloud is just one part of that. CI/CD is just one part of that. But DevOps as a whole, as I mentioned, it covers from infrastructure creation till monitoring your applications on that infrastructure. Sir, Fast University is teaching me and my classmates DevOps this semester, and software construction, software engineering 20th batch. Okay, yeah, so that is a good thing. But I'm not sure who would be teaching that, because if we who would have that experience in DevOps. What is SAM? Serverless application model. Obviously, SAM can have multiple meanings. I'm not sure what do you mean. If you mean serverless application model, then that's obviously, as I mentioned, that you can deploy your applications in a serverless model. You won't have to manage the server. You won't have to manage the physical server for it. For APM, which tool do you use to integrate with Slack, CloudWatch, or App Dynamics? Again, for APM, for application monitoring or anything, there are a lot of tools. We have Grafana Cloud. I have worked with Alert Manager and those things. So there is Datadog as well, which is a very good, but those are paid tools. Again, Prometheus, Grafana, Alert Manager, those are free open source tools that anyone can work with. So can we also teach DevOps after learning from this course? Again, depends on you. I only thing is that these slides and all of this material is obviously the intellectual property of me and Dice Analytics that you can't use, but that depends on you, whatever you want to do. Personally, I will not say no, but if you create your own content and those things, then you can go forward with whatever you want. Who will set up these monitoring tools like DevOps? DevOps will set up these tools. Devs only write code. That is what I'm trying to say, that devs should only focus on writing code, should only focus on writing features. DevOps guys should be responsible for the infrastructure, for the monitoring, for those things. Sir, since there are a number of tools within the company using one, yeah, that happens. If you see again the DevOps job description, they would have mentioned any of AWS, Azure, or Google Cloud, any of Prometheus or Datadog, or any of this, any of CI/CD or this. But again, as I mentioned, that you should have expertise in one of them, but be willing to learn others. What to prepare for a fresher DevOps interview? Again, containers, Git, Linux, CI/CD tools. If you have these, there are a lot of Docker containers interview questions that even in this course, we try to help you. There is a quiz every week, and that quiz is obviously based on interviews. I myself have been the hiring manager for 3 to 4 years for DevOps. So I used to take interviews of people for DevOps for 3 to 4 years now. So all the quizzes that we have in the class, in the course, are related to that interview questions. How do we able to, after completed this course, how do we able to, after, I didn't get this question. So how can we enroll this course and what is the criteria? So I believe Zainab has answered that. Sir, after taking you, can we also become British Asian developers? Yeah, I believe, yeah, you can. Will you teach practically? If you teach just theory, then how can we get practical experience? As I mentioned, that the course is 60 to 70% hands-on. There are labs, there are assignments, there is an actual project that you have to do. But obviously, those things you have to do. I cannot do the assignments for you. We give the assignments, we do the hands-on lab, we provide the lab, everything is hands-on. DevOps is a hands-on course, as I can assure you. Even in the hiring process, even when I hired people, we normally give a home-based task. Basically, we give the candidates a home-based task who passed the initial interview. We give them a home-based task to do. DevOps is a hands-on thing to do. It's not just theory. Is this course on-site or? But obviously, this session, this webinar was for 2 hours. I cannot do a lot of hands-on because already there are a lot of topics to cover. But if you enroll in the course, or if you take feedback from the previous students, this course is 60 to 70% hands-on, that I can guarantee you. Is this course on-site or remote? This is our remote. We have classes Saturday and Sunday. From this batch, even I shifted to Saturday and Sunday. Previously, we only had Saturday. But from this batch, we would be shifting to Saturday and Sunday, 10 a.m. to 3 p.m. With a 1 hour break in between. So, yeah. AWS cloud practitioner or DevOps, that's your choice. I cannot comment on that, because cloud practitioner, obviously, that specializes in cloud. But as I mentioned, that cloud is just one part of DevOps. In this course, we do not cover cloud things. We cover DevOps irrespective of cloud, because in the course, for example, 5 people will come who will work in an AWS based environment. Other 5 will come who will be working on an Azure environment. Other 5 might come who will be working on Google Cloud. So we cannot restrict it to a cloud. In this course, obviously, we do not restrict it to a cloud. We go cloud native. Basically, without any cloud, we try to cover all of the concepts, and that would be done. So if you want to focus on just AWS, then that course. But if you want to focus on the complete DevOps picture, as I mentioned already, the DevOps is not just cloud. DevOps is about CI/CD pipelines. DevOps is about monitoring, logging, and those things. Then those things. Sir, can buy V8 after this course. iPhone, I believe you are trying to be quite funny over here, but I personally don't think that you can become a British Asian developer or can buy V8 after this course. That totally depends on you. Sir, do you offer scholarships also that DICE administration can answer better? What to prepare for a fresher DevOps interview? Again, that container questions, CI/CD questions, CI/CD, those sort of questions you can try to focus on. What should be the best skill to learn for a beginner looking for a career in CS? development. If you want a career in CS, then obviously development, you should focus on development. CS is actually computer science, and that is based on the development. So focus on development, focus on languages. But if you want to focus on the DevOps part, that is deploying the code, then obviously that's a bit different. MashaAllah, Ali bhai, maybe really start learning and start doing. Yeah, inshallah. And I believe that's it from my side. Zainab, do you want to add anything?
All right, so that's all about the webinar. Thank you so much, Mr. Ali, for this great informative session. To all the attendees, DevOps training is starting from coming Saturday, 24th of September. Registration link is already shared in the chat section. You guys can reach out to us for any queries regarding our trainings at info@diceanalytics.pk. Thank you so much. Lafis.
Lafis.